We are working on 9.5, and we are doing the mean absolute deviation, or otherwise known as the MAD. First thing we have to do is right here. We have to find the mean of the data. And actually, we're going to want to put these numbers in the correct order so we can find the mean, but then we have to do some subtracting, so we just want to put them in the right order. So we got 2, 4, 6, 8, 10 numbers. We're just going to put them in the right order. We got 7, 8, 9, looks like a couple 10s, and looks like 11, and a couple 12s, and a couple 13s. Now, the first order of business when you are finding the mean absolute deviation, or MAD, is you have to find the mean first. Sometimes when you're doing these problems, they'll actually give you the mean, so you won't have to actually find the mean, but they did not give us the mean. I think this is number 2 in your record and practice journal. So we got to add all these numbers up. I've gone ahead and taken the liberty to add them up. If you add them up, it's 7 plus, well, I could show you the steps. 7 plus 8 plus 9 plus 10 plus 10 plus 11 plus 12 plus 12 plus 13 plus 13. If you add them all up, hopefully you'll get 105. Now we know there are 10 digits, 2, 4, 6, 8, 10. So we're going to do 105 divided by 10, and you're going to get 1. And it does not go into 5. Bring your 5 down, but it does go into 50, so we need to have a decimal. So it looks like the first thing we're going to figure out is the mean is 10.5. Now that's good and it's bad. It's good because the mean was actually not too bad to find. 105 divided by 10 is 10.5. But in order to complete that second step of the mean absolute deviation, we basically want to find out all these 10 numbers, how far apart they are from that 10.5. So essentially what we're going to do is we're going to subtract 10.5 from 7. We're going to subtract 10.5 from 8. We're going to subtract 10.5 from 9. We're going to subtract 10.5 from 10 2 times. Then I'm going to kind of slide it under here because it is absolute, so that means we want all of our answers to be positive numbers. We don't want any negative numbers. So we kind of have to put the 10.5 underneath, and I need to erase that so it is not going to be in our way. 10.5, and the last one, 13 minus 10.5. So essentially what we're trying to do is we're trying to figure out how far our data set is away from our actual average of 10.5. So now we just have to subtract. 10.5, go with a different color here. 10.5 minus 7 is going to be 3.5. 10.5 minus 8 is 2.5. 10.5 minus 9 is 1.5. 10.5 minus 10. 10.5 minus 10 is both 0.5. 11 minus 10.5 is also 0.5. 12 minus 10.5 is 1.5 and 1.5 again. And then 13 minus 10.5 is going to be 2.5 and 2.5. Now, it may seem a little redundant, but the next thing we have to do is we have to add all of these 0.5s and 3.5s and 2.5s and 1.5s. We have to add it all up. If you add it all up, again, I will show you by just simply putting a plus sign in there, but it's just add them up. If you add them up, you should end up with 17, and then we got to divide by the total number that we had, which is 10, and if we can do 17 divided by 10, we can find our mean absolute deviation. How many times does 10 go into 70? Put your decimal up. 10 goes into 77 times. So our mean absolute deviation is 1.7. So essentially what that means is our mean on average is about 1.7 away from our number set. So that's mean absolute deviation. You it's a wordy, lots of steps to complete this problem, But it all starts with the mean. You have to find the mean first, and then essentially what you're doing is you are subtracting your mean, 10.5 in our case, from your data, and then you're adding all these numbers up, and you're dividing it by 10. So your mean absolute data is 1.7. Good luck working on the MAD. It can be